Hi there, I'm Chris Saxon, the SQL Wizard. In today's episode, we're going to continue looking at ways we can get all the red sweets out of my party bags here. However, I've got a specific question I want to answer. I'm turning into a bit of a health nut, so I want to know the total weight of all the red candies, so I can figure out, roughly speaking, how many calories there are in them. We're going to take a look at techniques we can use to ensure we answer this question nice and efficiently. Ready? Let's get started. In the previous episode, we looked at methods we could use to just count how many of the sweets were red. And we saw that our document here had all the information we needed. We could just scan down it, counting the total number of red entries. This is what we called an index-only scan. This could be significantly more efficient than both a full table scan and an index range scan, where we still got to actually go to the bags to get the sweets out. However, to answer our new query, what's the total weight of the red sweets, my document here just isn't good enough. I can find which ones are red, but I've still actually got to go to the bags, pick out the red sweets to find how heavy they are. So how can we improve the performance of this query? Well, one way we can do is create a new index that includes both the color and the weight. This enables us to have an index-only scan again, so we don't need to pick up the bags at all. However, before we do this, there's an important question we need to answer. Which way round are we going to create the columns? Do we put weight first and then color? Or do we put color first and then weight? Which approach works better? Let's take a look. First up, let's take a look at what happens when we create our index with color first and then weight second. When we do this, we have all the entries in the index are sorted by the leading column first. So they're sorted by color, and then the weights are listed second. And when Oracle interrogates the index, it must look at the values in the leading column first. This means with red listed first and all those red entries right next to each other, we can restrict our search just to the entries that are actually red and find the matching weights. What happens when we flip the index around? So we've got weight first and then color. In this example, the columns are listed, the values are listed by weight and then color. This means that our red entries are scattered all throughout the index. And again, Oracle must look at the first column first and then check the second column. So this means it's got to search every single value in the index to find the ones that are actually red. Therefore, all things being equal, our index that has color first and then weight will be significantly more efficient than our index which has weight first and then color. Let's recap. We can see that the order you've listed columns in a multi-column index can have a significant impact on the efficiency of using that index. The leading columns in the index must be listed in the corresponding where clause of your query for Oracle to restrict its search to just those entries that match your search criteria. If those leading columns aren't in the where clause, then Oracle will have to inspect every single entry in the index. And this is what's called a full index scan. So to ensure you've got index-only range scans, you need to inspect your queries to determine the optimal column ordering. That said, if you do find yourself in a situation with full index scans, these are still typically more efficient than full table scans on the corresponding tables. Why is that? Well, usually the indexes are smaller data structures. In this example, our index is only storing 3 things: colors of the candies, their weights, and which bag they're in. The table itself is storing much more data. Not only do we have the colours and the weights, but we've also got their dimensions, their flavour, have they got manufacturing defects, and so on. So we've got more data stored in the table, so it's going to take longer to read. So provided your multi-column indexes have fewer columns than are in the base table itself, it'll be usually faster to do a full index scan of those than a full table scan of the table itself. I'm Chris Saxon. Thanks for watching. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.